We're going to see, then we have Spark SQL. What is this? Now, Spark SQL is a Spark component for processing structured data. A part of a big data framework of Apache Spark, it is mainly used to process structured data and implement SQL-like query. Again, users can perform the ETL performance, which is extract, transform, and load operations in data, different formats, and from different sources. And through Spark SQL, completing specific query operations. So you find Spark SQL is it does some query operations. Then we have here Spark streaming. What is Spark streaming? Now you find indicates the mini batch stream processing engine. Now, after fragmenting stream data, it uses computing engine of Spark Core to process the streaming of data compared with Storm. And again, it provides weaker real-time processing. Sorry. Then we have the MinRab and GraphX. These are algorithms, library algorithm. We have Fusion Insight Spark, runs on Yarn clusters by default. Yes. So what I want you to note here, just note what is the work of the Spark Core and understand the features of Spark Core, the Spark SQL. Those questions will come in the exam. Note that. Now, let's look at the core concepts of Spark. When we talk about RRD, we are talking about resilient distributed databases. And what is this? When you talk about resilient distributed databases, we are talking they are elastic, read-only, and partitioned distributed data sets. Now, RDDs are stored in memory by default and are written to disk when the memory is insufficient. Again, RDD is stored in the cluster as partitions, and you find RDD has a lineage mechanism which allows for rapid data recovery when data loss occurs. Now, I want you to, you have HDFS here, and we have Spark cluster, and we have the external storage. When you talk about RDD, resilient distributed data sets, it is the abstraction of the basic data by Spark. How are RDD generated? An RDD can be created from Hadoop file system, such as, you see, we have HDFS, such as HDFS. And number 3, storage, we look, user can choose different storage levels. User can choose different levels. And we have 11 levels available to store RDDs for use. You see, RDDs are stored in memory by default and overflow in the disk, and overflow in the disk because you find here, look here, we are saying RDD, they are generated by HDFS, and you find here in the Spark cluster, if there is insufficient memory, they can be stored in the external storage. Then we have RDD dependencies. Here we have narrow dependencies and we have wide dependencies. What is a narrow dependency? You see each partition of parent RDD is used at most by one partition of the child RDDs, and you find wide dependencies. Each partition of the parent RDD may be used by multiple RDD partitions, which is the basis of stage division. Now, an RDD remembers how it is evolved from another RDD using a lineage. Then you find we have some stage divisions of RDD. Now, it is very difficult to divide stages in submitted job due to the complexity of RDD dependencies. And in this case, Spark uses the narrow dependencies and wide dependencies. Now, Spark scheduler reserves the whole dependency chain from the end of the directed acyclic graph. I know this one is a bit technical, but just understand the concepts. I don't want you to give up. Then we are going to see how task scheduling of Spark is done. Now, the scheduler divides job into multiple stages. You can find we have jobs, then they are divided into multiple stages. And again, each stage corresponds to a task set. You find we have task here. Each stage is composed of a task set with the basic business logic, but different data. These task sets are eventually submitted to a task scheduler. You find we have task set, we have different jobs. They're broken into different stages. Then again, they are broken down into tasks, and these tasks are submitted to a task scheduler. And each task scheduler corresponds to a scheduler backend. We have a scheduler backend here. Now, task schedulers are responsible for scheduling different jobs of applications and initiating the retry mechanism when the task execution fails, and initiating backups for tasks with slow execution speed. And you find the scheduler backends interact with clusters. These are different clusters. Cluster managers such as resource managers to obtain resources allocated to the application and data transfer these resources to task schedulers. Then the task scheduler allocates computing resources to the task. We have RDD operators. This is one you need to understand. When you talk about transformation operators are invoked to generate a new RDD from one or more existing RDDs. Such an operator initiates a job when an action operator is invoked. Typical operators are, note this one you come in the exam, we have map, frat map, filter, and reduce by key. And what is an action? An action, a job is immediately started when an action operator are invoked. And typical actions are, this one will come, take, count, and save. Typical transformation operators and actions. And here we have some common transformation and some common actions. So don't worry about this more. These are more about, they are practical oriented more. Just major roles of Spark. Number one, driver. You see something we call driver. We have application master and client. Now, a driver is responsible for application business logic and operation planning. Then we have application master, manages application resources and applies for resources from resource manager as needed. Then we have client demand side that must submit demand side that must submit requirements. So those are some of the roles. Then still resource management, node management, and we have an executor. Now, an executor of a task, it's where an application is split for multiple executors to compute. What is a node manager? Node manager is resource manager of the current node. And what is the resource manager? Resource manager department that it schedules and distributes resources in the entire cluster. Then you find we said Spark can also run on Yarn. Again, Spark can run on Yarn. Again, we need to understand the differences between Yarn client and Yarn cluster. And you find is that Yarn client and Yarn cluster, both of them rise in the application master. And again, you find Yarn client is suitable for testing, whereas Yarn cluster is suitable for production. again, you find if a task submission node in Yarn client mode is down, then the entire task fails. In such a situation, Yarn cluster mode will not affect the entire task. Then we have typical word count. You find here, we are trying to look at how Spark does. Remember we said processing of data, and you find both of them are reducing a stored first. An apple, a pair of shoes, and orange apples. We have different RDD. RDD1 here still takes them the way they are. Then here they are broken in RDD2. Then again, they are mapped, they are sorted, and you have the final results. And what has happened, these final results, it is still stored in HDFS. Remember we said HDFS is one that is used for storage. So this is how Spark does a typical word count. And the purpose of this is to reduce these entries or these words that are stored here. When they are reduced, you facilitate there is high access, high throughput, and again, there is no redundancies, and again, the storage becomes efficient. This is how Spark, remember Spark and MapReduce, they operate the same. It's only that Spark does batch processing, real-time processing. It has some machine learning capabilities, whereas the MapReduce only does offline processing. Now let's see about Spark SQL, Spark Structure and Query Language. Spark SQL is the module used in Spark for structured data processing. In Spark application, you can seamlessly use SQL statements or data frame APIs to query structured data. So this is a module in Spark that is used for structured data processing by querying the structured data, Then data set. When you talk about what is a data set is a strongly typed collection of objects in a particular domain that can be converted in parallel by a function or relationship operation. A data set is represented by a catalyst logic execution plan, and the data is stored in encoded binary form, and the sort, filter, and shuffle operations can be performed without deserialization. We find dataset is lazy and triggers computing only when an action operation is performed. Now, when an action operation is performed, Spark uses Query Optimizer to optimize the logical plan and generate an efficient parallel distributed physical plan. That's about dataset. You can read more. Then data frame. What is a data frame? Every dataset must have a data frame. Data frame is a dataset with specified column names. You find data frame is a special case for the dataset. You find these are data frames. Data frame is with specified columns. These are data set. You find you have person, a set of data. But when you talk about data frame, it's where we have now data sets that are classified with the name. You find we have the name, we have the age, and we have the height. So at least understand the differences between a data set and a data frame. That will come in the exam. Then RDDs, data frame and data set, you need to look at the advantages of RDDs. They are 7 object-oriented number. Disadvantage there, high performance. When you talk about data frame advantage, yes, there is schema information to reduce serialization and deserialization overhead, and disadvantages not object-oriented. And it's insecure during compiling. Again, characteristics of data set. These I know you can read them. They are fast, secure, etc. Then we have Spark SQL, the differences, and Hive. When you talk about the differences, the execution engine of Spark SQL is Spark Core, note that. The execution engine of Spark SQL is Spark Core, and the default execution engine of Hive is MapReduce, note that. Execution engine of Spark SQL is Spark Core, and the execution engine of Hive is MapReduce. Again, the execution speed of Spark SQL is 10 to 100 times faster than that of Hive. Then again, Spark SQL does not support buckets, but Hive does. You remember when we were looking at Hives, we looked at what are buckets. Then when you talk about dependencies, Spark SQL depend on the metadata of Hive. Spark SQL is compatible with most syntax and functions of Hive, and Spark SQL can use the custom functions of Hive. Then we have structured streaming overview. Remember, it's like we are looking at, when you see, we looked at the architecture of Spark. It's like now we are looking at each and every part. What is structured streaming? Structured streaming is a data streaming processing engine built on Spark SQL engine, and you can compile a streaming computing processes like static RDD data, and when streaming data is continuously generated, Spark SQL will process the data incrementally and continuously and update the results to the result set. Then you can see structured streaming overview. We have a data stream, and we have unbound table is equals to new data in data stream, and is equals to new rows appended to unbounded table. Then a programming model for structured streaming. Then examples of structured streaming. These ones they'll not come in here in your exams. Overview of Spark streaming. Let's maybe see Spark Apache Core API, which is a real-time computing feature with scalability, note that, high throughput and fault tolerance. And you can see here we have Spark streaming, we have Kafka, we have HDFS, we have Spark streaming, then we have HDFS, Kafka, and the database. So you find Spark processes the data that is stored in either HDFS, in Kafka, and no, Kafka, remember Kafka is we said it's a messaging system. Yesterday we looked at Kafka and we looked at Roda. Then again, we are looking at Spark streaming. Programming is based on dstream, which decomposes streaming programming into a series of short batch job. You can find we have input data stream, then we have Spark streaming. These are the batches of input data, the Spark engine, and the output is small batches of jobs. Then fault tolerance mechanism. You find Spark streaming performs computing-based RDDS. If some partitions of RDD are lost, the lost partitions can be recovered using, note this one will come in the exam, can be recovered using RDD lineage mechanism. And here there is a comparison between Spark streaming and Storm. I want you to go and read this. Also, this one will come in the exam, the differences between Spark streaming and Storm. This is how Spark in the web user interface. if we have the Fusion compute software, you could have seen, but you see in this web UI, you can see the status. We have instances, we have configuration and resource distribution. And if you look at the Spark summary, you find something we call health status. It's good. Configuration status, it's synchronized, the version, and the Spark web UI. Don't worry, when we shall be doing the practical, we shall look at that. Now, permanent processes of Spark. Now, Spark resources does not have permanent process. The configuration of jar files of this role are used when Spark application job is submitted. I need you to understand what is a JDBCS server. Now, it is a permanent Spark application that provides Java database connectivity service. Note that it is a permanent Spark application that provides the Java database connectivity. That one will come. And when you're using JDBC server to execute SQL statements by running something we call brin and again JDC script, these things you see them in when we are doing the practicals. Then we have the job history. I know it's a bit tricky to teach such a unit that requires these things. You should be seeing them practically, but something we are working hard for you to have it. Then Spark and other components. You need to see in Fusion Insight Cluster, Spark interacts with the foreign components. Spark interacts with HDFS, interacts with Yarn, interacts with Hive, interacts with Zookeeper, interacts with Kafka, and again, it interacts with HBase. Now, we're going to look at the questions. Then what we are going to do, because I don't have power and my computer is almost going down, it's only tomorrow that we are not meeting because I have a face-to-face class in town. So before I make it back home, it will be a bit late. We're going to start on Wednesday. Before we look at the question, we are going to continue on Wednesday. On Wednesday, we are going to start with revision. We start with revision of maybe 3 units. Then we look at the Frink. On Thursday, we look at the revision, then we look at Frium. On Friday, we look at the question, then we look at Fusion Insight HD. So we have 3 more units remaining. I thought we could have covered 3, but it's impossible. We have 3 more units remaining. We have Frium, we have Frink, and we have HDFS. Revising questions and the other hour to cover on Wednesday. On Thursday, the same, we do the same. On same, we do the revision. Now, I'll give you maybe Tuesday on your own, revise on your own. By Friday this week, everyone should have done the mocks and send me the results. By Friday this week, everyone should have done the mocks and send me the results, please, because one of the rules, you must pass the mocks. The mocks prepares you on how you will do the exam. So make sure we do that. And there are some students who have not been attending. Now, it will become a disaster now. Now, what are some of the characteristics of Spark? What did we say? Maybe you can highlight them.
It's fast.
Very good, fast.
Smart and flexible and even light.
Very good. Yes, very good, Jackson. I can see someone posting. Yes, we see some of the characteristics. That's right, fast, flexible, and smart. Now, what are the advantages of Spark in comparison with MapReduce? We have looked at them. Maybe let me give you this as an assignment. You go and read them and what the difference between wide dependencies and narrow dependencies. But maybe you can tell me what are some of the application scenarios of batch processing of Spark.
There is machine learning.
Yeah. Yes, machine learning. Another application. We have said machine learning. We have said interactive analysis, stream processing, and batch processing. Batch processing. Note that. Then you look at RDBs are classified into transform and action. Let me ask this. The Dutch module is the core module of Spark. The Dutch module is the core. Yes.
The Spark core.
Very good, Desire, the Spark core. And RDD dependency types include the wide and narrow. Very good, very good. So what you do, go through those notes and questions. I'll try to look for a password. I have some more questions. I don't remember the password, but I'm looking at it. So what you do, revise those questions that I've shared, revise the questions. On Thursday, we are looking at each question individually and each unit or each component with its own questions on Wednesday, Thursday, and Friday, and maybe probably Saturday and Sunday to prepare you for the exams next week. I don't have power. My laptop is going down. Let's meet on Wednesday. Are we in agreement because of tomorrow?
Yes.
Oh, thank you, thank you. Wow, thank you. Yeah, this is a student who has reminded me. Actually, let me post those questions now, please, as we wait there. Actually, the password is 12343221. Thank you, thank you. Now, what we can do, I'll share the questions. You can leave the meeting. I will put the question, at least I've gotten the password. Thank you so much, Basia. Let's meet on Wednesday. So,
excuse me, sir.
Yes,
Before
please.
we leave, the question
Yes.
Gishuki has asked about iLearning X, we're still not being redirected to iLearning X. Once and enrolling after enrolling for the course.
Let me talk to Kenodia right now. Don't quit. Let me talk to him right now.
Okay.